Okay, let's keep going. So 46b is a similar question. It's about a quadratic function. So we see this one is a quadratic function, downward parabola again, where the graph is like this. So when we're looking for the maximum height, that's this vertex again. And when will it attain this height, right? That means x value. So this is a t time, and this is s of t, right? The vertex t, and so this point. So we're looking for this point t, s of t. So how do we do that? Again, vertex, right? T equals to negative b over 2a. What's b? B is 64. Over 2a, what's a? A is negative 16. Again, negative and negative become positive. So 2 goes into 64, 32 times. 16 goes into 32 2 times. So 2 hours later. So 2 hours later, the object will obtain this height. What's the height? We have to calculate s of 2. So s of 2 is negative 16 times 2 squared, then plus 64 times 2, then plus 80. So negative 16 times 4, that's negative 64. Plus 2 of 64, that just becomes 1 of 64. Then plus 80, which give us 144. So 2 hours later, the object will reach its maximum height, which is 144 feet. All right, now let's look at 27. 27, we want to graph a function using transformations, vertical, horizontal shifting, reflection, and vertical horizontal stretching, which means the dilation or shrinking. So we have this x cube, right? Let's remember x cube graph. It's good to remember the reference graph. Let me graph in blue color. So x cube graph wiggles at the origin, right? So this is the x cube graph, wiggles at the origin. And the first quadrant and the third quadrant, the graph looks similar. Now we see x minus 1. That's a horizontal shifting 1 units. So let's see, this is 1. So that means the graph x looks like this, x minus 1. Then reflection reflects the positive y value to be negative, the negative y value to be positive. So now this part becomes down here now, symmetric with x-axis. Oops, I didn't draw it right. More like this, right? Then this part comes up now, like this. So that's symmetric with x-axis. And now, so that's the reflection negative. Then we shift this graph down 2 units. So let's see, this is 1, this is 2. We shift down this graph 2 units. Now, the new axis, it seems like this here. So we have a graph at this point, which is negative 2, comma 1. It will wiggles at this point. So this is our graph. This is our graph. Negative x minus 1 cube minus 2. So this negative 1 is a reflection, right? This x minus 1 is a horizontal shifting to the right 1 unit. This negative 2 shifts down the graph 2 units. So you can work with a couple points. You see, I work with these points where the graph wiggles by remembering the reference graph. Now, piecewise function. Piecewise function means the function being split into a couple parts. But in this case, it's being split into 3 parts. Let me erase this. Erase this, I need space. Getting back to my pen. So you see the domain being split into 3 parts, x less than -2. So let's graph x-axis. Oh, sorry, y-axis is supposed to be very strict. So let's see, this is -2. Less than -2, that means open circle, right? From here downward. So that's one interval. So from here down to -infinity, one interval. Then from -2 to +1, let's see, +1 is here. And this is the second interval. Second interval including -2, but not including 1. Third interval is x greater than 1, including 1, up to +infinity, right? 3 intervals. So in each interval, the function defined differently. So in the first interval, less than -2, the function is 2x. So how do we graph f of x equal to 2x? We'll think of y-x equal to 2x. Well, if x, so we have to start with -2. So if it's -2, -2 times 2, we get -4. So let's see, this is a -4. So we will get this point. But because -2 is not in the domain, so we make an open circle. Now, then we'll have to find another point. Let's do -3. If it's -3 times 2, that's -6. Okay. So even going down like this. So this is our graph. So this is this piece. It keeps going down. Starting from this point, -2, -4, then going downwards like this. That's the first piece. Second piece is a 3. So in the interval, so let's see, this is a 3. In the interval from -2 to 1, it's a 3. Because -2 is in the domain of the second piece. So I'm making a solid dot. Okay. But 1 is not in the domain of the second. So I'm going to make an open circle. That's the second piece, constant. So the function is constant, it doesn't depend on x. And last piece is x greater than or equal to 1. So we start from 1. If x equals 1, this is 0.1. 6 minus 1, that's 5. So let's see, this is 5. Let's see, this is 5. So I have this point, solid dot, right? Because 1 is in the domain of the third interval. Then I need another one. Well, let's do 2. If x equals 2, 6 minus 2, that's 4, somewhere here. So with the 2, so this is a linear graph, linear function. With the 2 points, I can graph. I have this three pieces, right? You see, in the first interval, I get this piece. In the second interval, I get this piece. In the third interval, I get this piece. So that's why it's called a piecewise function. Okay, 49. We want to graph this exponential function and identify domain and range. So how do we graph this? So let's simplify this a little bit. You see this, we don't really need to. Okay, let's just evaluate f of 0. That's 2 raised by 0 plus 1, which is 1, just 2. Then maybe we do f of -1. That's 2 raised by -1 plus 1, this is 0. So that's 1. So remember the base is 2 is greater than 1. So we have exponential growth, reference graph. Always remember reference graph. So the behavior of the function like this. So now we have 2 points, by -1 and comma 1. So let's see, this is a -1. This is 1. So this point will be -1 comma 1. And then when x equals 0, we have 2. So that means that this one is 0 and comma 2. All right, so this is the graph. That's it. So with the 2 points, you can do three points, all right? But the important thing is to remember the reference graph. So how does the graph go? So that's 49. 50. We want to use compound interest formula, right? This is a compound n times. So in a year, compound n times. Remember P, A represents the money in the financial institute after T years. So T is years. And P is the principal, is the starting money putting in the account. R is the annual interest rate. N is how many times the interest being compounded. Interest can be compounded yearly. That means N equals 1. Can be compounded semi-annually. That means N equals 2. Can be compounded monthly. Compounded means the interest being calculated, then the interest will be added to your principal. So the interest becomes your principal. That means compound. If we compound weekly, so in a year we have 52 weeks, so N equals 52, so on and so forth. If you compound continuously, what does that mean? Continuous, that means every moment you can think of it, the interest is being calculated and added to your principal. That's compounded continuously. All right, let's see example 1. So the investment 2,500, that's our P, with 3.5%, that's our annual interest rate. Compounded monthly, that means N equals to 12. For 3 years, that means T equals to 3. So we want to find A. So amount of money in the account equals to 2,500 times 1 plus interest rate is 3.5%. We want to write as 0.035 divided by compound monthly divided by 12. Then raised by N times T, right? 12 times 3. Then we have to use calculator to calculate this, all right? So when we put it into the calculator, make sure you want to put the 2,500 multiplied by parentheses. Then 1 plus, inside the parentheses, you have 1 plus 0.035 over 12. Then parentheses raised by 12 times 3, which is 36. All right, because the order of operation is very important here. Well, if you could, you do 1 plus 0.035 divided by 12 first. Then you raise this by 36. Then in the end, you multiply by 2,500. All right, because sometimes if the order is not exactly right, it give you, untrue number. Now let's see B. B is P equals to 10,000. Annual interest rate is 2.7%, compounded continuously for 7 years. So we got continuous, we're gonna do the second formula. So 10,000 multiplied by E. E is the Euler number. If you press into calculator, that's 2.718, keeps going on, just like a pi. Then R is 0.027, which is 2.7%. Then multiply by years, 7 years. All right. So punch this into calculator as you do E first. Okay, E is one key on your calculator. So you do E raised by 0.027 times 7. Then you multiply by 10,000. All right. 51. Finding composition of two functions. So this F composed with G. This means F takes G as input. Right. How is G defined? G is defined as 3x minus 5. How is F defined? F is the square root of the input. The input is 3x minus 5. Then add 7. Simplify this. That's a 3x plus 2, right? Because 7 minus 5 is 2. Just be simple, okay? Don't think complicated. Sometimes we make mistakes because we overthink. It's very simple, right? F composed with G just means F takes G as input. 52. We want to verify if the two functions are inverse with each other. If they are inverse with each other, when we do the composition of those two, we get identity function. We get X. Okay, total we have 58 questions. Okay, let's do F composed with G, and then we do G composed with F, which means F takes G as the input. So that means F takes 3 minus 5x divided by 4x as the input. How is f defined? F says, okay, do 3 divided by 4 times the input. The input is 3 minus 5x divided by 4x. Then add 5 to it. So I have to simplify to the calculation. So here we see this 4 cancels with this 4, right? So I have 3 divided by 3 minus 5x divided by x plus 5. Well, plus 5, we want to write as 5x over x, right? In this case, we can add those together. Oh, we have negative 5x, we have positive 5x, those cancel each other. So we have 3 divided by 3 over x. Well, that's 3 multiplied by x over 3. These two cancel. Bingo. So we did get x out, right? So f of g of x equals x. Okay. You see, in the beginning, we push x into the machine G, then we push g of x into machine F, then we get back x. So we call this identity function. Well, now let's do G composed with F. Means G takes F as input. So how is F defined? As 3 divided by 4x plus 5. How's G defined? G says do 3 minus 5 times the input. What's the input? Input is 3 divided by 4x plus 5. Then divide this by 4x. Okay. So we have, let's simplify the numerator. So I have 3 minus the 5 times 3 in the numerator, that's 15. Divided by 4x plus 5. Then everything divided by 4x. Now 3, I want to multiply 4x plus 5 because I need a common denominator to simplify, right? So I want to do 3 times 4x plus 5, subtract 15, then divide by 4x plus 5, then divide by 4x. I have 3 layers of this. So the numerator, I have 12x plus 15 minus 15. Do you see this? 3 times 5 positive 15, then minus 15, that's gone, right? So I just have 12x in the numerator. Then I have 4x plus 5 in the denominator. Then divided by 4x is the same as multiplied by 1 over 4x. Now I can perform simplification, right? So 12x, 12 divided by 4, that's 3. X divided by x, that's just 1. So what do I get? I get 3 over 4x plus 5. What is 3 over 4x plus 5? That's f of x, right? That's f of x. So what do we see about this? No, those two are not inverse with each other because when we do f composed with g, yes, that's good. But when we do g composed with f, so g takes f as input, we do the calculation, in the end we get f of x out. Get f of x out. We don't get x out, we need to get x. If we do get x, that means they're inverse with each other. Okay, let's see 53. So we want to convert in between exponential and the logarithmic form. So here we have log base 4 of the value half equals a negative half. We want to write it as exponential. Base in the log is a base in the exponential. So 4 raised by negative half equals to half. And that's it, very simple. And this one we want to write as log. So log base 1/3 of 1 over 9 equals to 2. Evaluate a logarithmic expression. So let's see this one. So we want to write as log base 2, 4 raised by negative 1/3. You see, this is cubic root. That's 4 raised by 1/3, right? But it is 1 over it, so we can write as 4 raised by negative 1/3. Then 4 is 2 squared. So we can write 4 as 2 raised by 2 times negative 1/3. Well, 2 times negative 1/3 is negative 2/3. So then these exponents can go up front of the log. So we have negative 2/3 of log base 2 of 2. When the value and the base are the same, that becomes 1, because 2 raised by 1 equals 2. So the answer for this is just negative 2 over 3. Now let's see 55. We want to graph this function. Identify domain and range. Domain is x minus 1 greater than 0, which means x greater than 1, right? And then we see we have a horizontal shifting and vertical shifting of the reference graph. Remember, the reference graph is this, right? Looks like this. This keeps going down. This keeps going up, and we have this 1, 0 point. But now the function is being shifted. Let me use red color. Shifted 1 unit to the right. So now it becomes here. So the vertical asymptote becomes at a 1 now. X equals to 1 becomes the vertical asymptote. In the reference graph, y-axis is the vertical asymptotes. Then plus 1 means every point being shifted up 1 unit. So this point was shifted here, now shifted up 1 unit. So the graph looks like, still have this shape, all right, looks along this line. So that's the graph, right? So the domain is x greater than 1. What about range? Range is all real numbers, because it keeps going down, it keeps going up, so it covers all real numbers on y-axis. Let's say 56. We want to find the distance between those 2 points. Remember the picture? Let's see 2 points here. The distance between those two is the hypotenuse of a right triangle. That's the difference in x value, the difference in y value, then square both, then we get a hypotenuse squared. So it's exactly like that. So distance, so we have square root. Let's call this first point x1, y1. Let's call this x2, y2. So the distance formula is in find the difference in x component. 3 minus negative 2 becomes 3 plus 2 square. Plus y2 minus y1, negative a minus 4, then square. Difference in y square. So then we do the calculation. 3 plus 2, 5, 5 squared. Negative a minus 4, that's negative 12. Negative 12 squared is positive 12 squared. Because when you square a negative number, you can still get a positive. So we get 25 plus 144. We get 169, which is 13 squared. Square cancel out square root. So the distance is 13. In this pure mathematics, we don't care about the unit. Okay, only in life applications, we care about the unit. So for now, just pure mathematics. Okay, no units. Just so distance 13. 58. Find the equation of a circle in standard form. So come on this way. So this is center and the radius is 3. Right? So edge k. Remember the circle formula is x minus h squared plus y minus k squared equals to r squared. So just follow this formula. And the h equals to negative 1. X minus negative 1 becomes x plus 1 squared. Plus y minus k, which is 2 squared. Equals to r squared. R squared is 3 squared. 3 squared is 9. And that's it. Okay. Mathematics is supposed to be simple and direct. Okay. Don't overthink. Oh, that's it. We're done. I'm done. Okay, now I'll see you tomorrow. Okay, hopefully by tonight you can finish all the reviewing. So see you tomorrow. Good luck. Okay.